Atlas is the first CubeSat designed by Project Jupiter. It represents a new mark in our group, broadening our understanding of space technology towards a new field, satellites. Atlas' mission is to detect fires in the Cerrado region, which is a Brazilian biome known for its natural wildfires. However, due to the advance of the agropecuary in the region, human-caused fires have been destroying the ecosystem faster than it can heal, affecting its natural balance and threatening many fauna and flora species. The area between Poconé, in the state of Mato Grosso, and Passagem Franca, in Maranhão, is the one chosen to be monitored because it concentrates higher incidences of fires in the region. Therefore, the orbit was chosen to ensure that the satellite will pass through the desired area at least once a day for 4.3 minutes, with an altitude that allows the fire to be properly detected. The orbital parameters are altitude 561.24 kilometers, inclination of 40 degrees 11 minutes and 33 seconds, longitude of the ascending node when the satellite passes above the midpoint of the arc AB minus 36 degrees 25 minutes and 55 seconds, and the shape of the orbit is circular. Atlas shall detect fires using an XI400 infrared camera. This module was chosen because it has a spectral range of 8 to 14 micrometers, a resolution of 382 by 388 pixels, allowing a spatial resolution of 1 kilometer, and is economically viable. Although there are different methods for fire detection, the team opted to use a camera sensitive to wavelengths in the long-wave faded spectrum. Firstly, because it allows monitoring during day and night, which doesn't happen with RGB cameras. Secondly, because although it is not optimal, fires can be detected in such spectrum. Atlas is a free-use structure made of aluminium 7075. It was designed according to the standards imposed by the competition and international standards. To use the space efficiently, we use the PC104 standard, stacking PCBs with the electronics for the subsystems. To allow for study and versatile placements and dimensions of the boards, threaded rods were deployed to fixate them. The Electric Power System EPS shall provide enough power for the satellite to operate effectively. Atlas is expected to have an average consumption of 6 watts for normal operations. In order to provide such power, the SM-SP3X solar panel, designed by NPC SpaceMine, was chosen because, among other characteristics, it has approximately 30% efficiency. To take most advantage out of the solar panels, a maximum power point tracking system will be employed in a microcontroller using a perturb and observe algorithm to keep the power drawn from the panels at a maximum without causing electrical problems. Additionally, to provide power while the satellite passes their shadows or when the solar radiance is low, the Optimus 30 LiPo batteries were chosen because they are rechargeable, have a high energy density, a long life cycle, and the desired capacity of 3 watts per hour. Moreover, this component also has a system to prevent thermal runaway in addition to circuits to prevent undervoltage, overvoltage, and overcurrent. Finally, the system counts with voltage regulators to provide each component with the necessary power, and thus, it shall provide 3.3 or 5 volts for the different sensors and subsystems. The onboard and data handling is a subsystem that deals with data received from the different sensors and subsystems. The core of this subsystem is a Nucleo F746ZG microcontroller from the STM32 family. Its main strengths are good processing power and a great number of communication interfaces which will be used to communicate with the sensors, such as I2C, SPI, UART, USART. Additionally, it has an external memory for data storage with SD cards. Moreover, this subsystem is responsible for pre-processing the data acquired by the camera and from the other subsystems, so they can be sent to the ground station for further analysis. The altitude determination and control subsystem is responsible for measuring and controlling the CubeSat's altitude and also for maintaining the camera and antennas pointed towards the Earth. This system is composed of magnetometer, oscillator, gyroscope, sun sensors, magnotorquer, and an STM32 microcontroller for performing the calculations necessary to altitude control. All these sensors, actuators, and also the microcontroller were chosen based on low power consumption, low mass, and relatively high precision, which are essential characteristics for the CubeSat's components. The TT&C provides detail regarding the satellite's status, determination of its location through tracking range signals, and the uplink commands given to the platform. For data transmission purposes, we selected Nanocom AX100, a miniaturized transceiver from GOM Space. This device caught our attention due to its capacity to operate in low UHF band and data rate up to 38.5 kilobytes per second. Besides those features, this transceiver also comes with built-in space protocols such as high-level data link control and the CubeSat Space Protocol (CSP). The ground station shall be able to receive the fire's coordinates detected by the satellite. Additionally, it should receive data about the CubeSat's position, its flight status, and the general flight data. Finally, the thermal control subsystem is responsible for ensuring the temperature is adequate for the operation. It was chosen as a passive control system using multi-layer insulation MLI. MLI reflects solar radiation, maintaining the instruments at an adequate temperature to operate while in the presence of sunlight, and keeps the heating, protecting the instruments from the cold while in Earth's shadow. The project was started in Phase 0, which took place at the beginning of 2021, and was mainly focused on the definition of the mission. Moving further to Phase A, which happened in the first semester of 2021, the team made feasibility studies, drafted a preliminary architecture for the systems, and defined the system-level requirements. Currently, our project is in Phase B, which consists mainly of preliminary design and technology completion. The next phase are going to be Phase C, that consists of final design and fabrication. Phase D, in which the system will be assembled, tested, and launched by the year 2023. Then, in Phase E, Atlas will be operating to detect fires in the Cerrado region. And finally, by the year 2024, Phase F will begin, in which the satellite will be decommissioned. Since Atlas is the first CubeSat designed by the team, we opted to use mainly commercial off-the-shelf components with flying heritage. It is estimated a total cost of 193,000 Brazilian reals, of which 30,000 are for sensors, 15,000 for the infrared camera, 20,000 for transmission equipment, 88,000 for solar cells, 20,000 for GPS, and 20,000 for batteries. So that was a quick overview of Atlas, Project Jupiter's first CubeSat and pioneers towards the group acknowledgement of satellites. Thank you for watching.